Welcome back, guys. Now, there's some people that write great code, and there's other people that can run great open source communities and be there for new people looking at the project. And there's other people that can lead a project in a strong direction, but rarely do you find all three traits in one person. There's one exception, and his name is Daniel, and he's here to talk about Kamailio.
Thank you, Simon. Thank you. So I'll have a presentation today about Kamailio, the project I'm somehow leading. At the beginning, I'll give you some updates about more or less the last 2 years, what we have new in the project in terms of features, the direction of the development, and then I'm walking through some tips and hints on using Kamailio on various scenarios, so you can optimize on using it for classic telephony, voice over LTE, or WebRTC going into either cloud and IoT kind of deployments. So that part, it's more about the, some sort of hidden features that might not be, in the front page of the features list, but could help you in those cases. So first about myself, I started a long time ago with what was at that moment SIP Express router, the project initiated by Fraunhofer Focus Institute in Berlin, Germany. And I was a researcher there, evolving over time in the reference implementation of this session initiation protocol. And as it got into more commercial demands, the Institute somehow discontinued to maintain it as part of their research activity, and we started to do consultancy and other business-related activities. I'm more or less leading the project, but otherwise right now it's community-oriented project, so there is no big company behind it. We have large companies that contribute, like the Second Telecom in Germany, the 1&1. Also other guys involved here having large deployments, like probably you have seen the SIPgate team. They also are part of the project, helping with the various needs. So let's start with the content. So practically, we keep a rather high pace of adding new features, because I kind of counted, and we have around 50 active developers per year, with a couple of hundred across all these years. The project started in 2001, being released as open source in 2002, so it's rather old by now, but in average we kind of add around 10 new extensions per year. So it's about these modules, how we reference it, but you could see from the list I provided there are different directions from the IMS, like open charging system, including some SS7 operation that you could do when you get it transformed into like a JSON operation inside Kamailio and work with it. I will have a dedicated section for this configuration of file scripting languages, what we call the Kemi framework lately. So practically, besides our native scripting language, you can choose your favorite scripting language for deciding SIP routing. So you could use like Lua, Python, and so on. Again, I'm going to come back to it. A lot of work on scalability. It's, let's say, for Kamailio project, Redis got quite popular in the community, so there are companies contributing a lot on like connectors from the config file, or having like a backend, database backend, so other modules that are already implemented and expected to work with like MySQL Postgres, they now can connect to Redis in the same fashions. Distribution of the states using message queues like NSQ, RabbitMQ. also work with other protocols because they are related in our environment, like would be MSRP, but in our case here, a lot of work was done with Diameter, which is tightly integrated with SIP for voice over LTE, IMS. I have some links at some point, but it's good to announce it from now. We kind of have these use cases of Kamailio approach during the Kamailio World, and we have all this presentation in our website. So, for example, if you want to use Kamailio as a Diameter server, there was a presentation by Carsten Bock 2 years ago showing that using Kamailio not for SIP and VoIP, but as a Diameter server only. So I'll come back to this because, again, there are a lot of features. I'm not really focusing on the main ones, the usual scenarios, because that's well approach in different contexts. I'm trying to highlight what's new or what's a bit hidden but still useful. So Kemi framework started to become quite popular for those that are familiar with Kamailio. You know, our scripting language was something brewed from scratch, maybe not the best designed scripting language, lacking some feature you might need, like, I don't know, some particular string operation, like extracting some token based on some condition. We have regular expression or other tokenizer parser, but still, from time to time, someone comes and says, how I can do that operation, which is not SIP related. And then we are a C application, we'll have to extend the scripting language with new operation, which is not our target. And another limitation or feature that was demanded in the community was the ability to reload the routing logic without restarting Kamailio. Although Kamailio doesn't really keep a lot of states that a restart will actually kill active calls, still in some situation, like maybe you don't want to drop active TCP connections, it's useful, and you discover, oh, I need to change from like checking request URI username and checking the two-header username, so it's a small variable that you want to change. You could do now this with other scripting languages. Practically, we had support for these scripting languages, what we call like inline execution. So inside our Kamailio config file, there was some function like Lua run, and then you have a parameter that is a name of the function from a Lua script that was loaded at startup. So a lot of these features were available, but mainly like execution through a specific function of Kamailio configuration file. What Kemi did, this Kamailio embedded interpreter interface, how I call it, it's unifying in the way that exporting a function is now visible in all of these scripting languages, including the Kamailio configuration file. Of course, we have to catch up with what was exported already to the old Kamailio configuration file. But now, practically, when someone has a new function, it should be available in all of these languages. As a summary, of these scripting languages that we support. Some of them don't implement yet the interface for Kemi, so we have support for Perl, .NET scripts or object files, but those are not yet extended for Kemi interface. But we have like Python, Python 2, Lua, JavaScript, Squirrel, and I added recently Ruby, as it was a demand at, or a question at the Kamailio World 2018, like 1 month ago. And surprising, embedding Ruby was rather simple to do it in C. I have to say I'm like a computer science engineer. I studied like making programming languages, so something it's something I'm familiar with. I no longer do that. And actually, I'm not coding in all these interpreters that I'm adding support for it. So probably I did a patch to some Python or Ruby application I used in the past, but I'm not something that I'm coding. So I'm relying on community to really test it. For myself, I'm using mainly Lua when I need to use a scripting language other than the native one. So the native one is still going to be there, but it got into this kind of target, be very optimized for really SIP routing. And then as we optimize and we kind of precompile and we have references in memory, restarting makes it harder without, like reloading without restart makes it harder. On the other hand, actually based on tests, if you use Lua or other embedded interpreters like JavaScript or Squirrel, the execution is in pair of like performances. Python, I have to say, it's a bit slower. Not that much slower, so you still get with Python like a couple of thousand registration per second. It's what I measure when I implemented. The thing here, who implemented first the Python module the Python module in Kamailio, he made it like a pure oriented object approach by initiating a new dynamic object for each SIP message. So that takes a bit longer. With the other interpreters, including the Ruby, what I did as I wrote them from scratch, I export as a static object. So practically just appears as an API functions. With each new message, we don't create a dynamic object. So we just pass the SIP message as a normal parameter instead of being the self object for that script. I've been discussing because now it's an active developer for the Python modules, and he was considering to looking at this approach because he's not the original developers, but as we discussed, he found out that could bring some improvement. On the other hand, based on the community feedback, I get it like Python being the most popular in terms of these companies that are using the Kemi framework. So a lot of them are still using and it's my preferred scripting language still, the native one, and it's, again, as we add a new feature, it's practically available in all of them, and that's not gonna change. This here, it's practically an example of a route block as we had it in the native scripting language, and we still have it. I'm just wanted to highlight how it looks the same kind of routing logic that you can do now in the native scripting language with other scripting languages. So for example, this would be with Lua. So practically what is a route block in the Kamailio CFG, you have to write it as a Lua function. It's up to you to choose the name, it's up to you to make it even with parameters and so on. What we define are the equivalent of the request route, the equivalent of the reply route. So these are the events for handling the request or the reply, and from there you can make your routing logic. What we export is practically this KSR, which could be like a library module or could be like a static object, depending on the scripting language and the model. But always it's more or less like KSR dot, and then practically you have some function like the equivalent of checking myself, getting a variable, or adding a header. So these are the functions that you use. Typically it's like appending KSR dot, and if it's from core, is the function name. If it would be like a module, like TM, would be tm.trelay, for example. Now, Lua, it's rather popular, and if you want to look more about it, also Sebastian, which is here, did some work from SIP Gate. The benefits, for example, what Sebastian presented at Kamailio World, it's actually making a testing framework for your configuration routing logic. So practically before putting it in the production, you can test the config file written in Lua better than would be with Kamailio, because Lua itself has other mechanisms for testing and so on. The next example, just to compare, would be the Python. So a part of a different way to define a method or define a function in Python, which would be here, you could see a lot of similar code like KSR object, is myself, KSR HDR append, so looks more or less the same code. So we tried to make it easy from like even migrating a Kamailio config written in native scripting language. It's a lot of just putting this KSR dot something in front, like the module name. Right now, there are thousands of functions exported to the Kemi framework, so it's pretty much in pair for most of the modules we have in Kamailio. There are a couple of categories, like I haven't worked a lot with IMS modules, so I haven't exported from those modules the functions to the Kemi framework. But otherwise, also the name, we try to keep it more or less the same, because actually we lack a bit of documentation. We have an index, so you can easily see the prototype, like what's returning, the name, the type of the parameters, because it could be integer or string, and it's up to you to combine them. But for the real documentation, you somehow have to go to the module documentation of the native scripting language. The behavior is the same. Is just a different approach of using it. So this would be the Kemi framework. Again, more you could see. I did a workshop at Kamailio this year. I have all the recordings, and the slides are now online. Again, at some point, I have the links to it. One of the features that somehow got a bit highlighted during the last months or past year was this transparent proxy. So practically, you know, as a proxy, whenever you process a SIP message, you had to remove some headers by the protocol. We had this feature for a very long time, probably more than 10 years, like just pushing out without changing anything in the header of SIP. So you can delegate the processing of that message. Could be like a request or a reply to another Kamailio. So it was the transparent proxy. However, what I did lately was adding some helper function to make it easier to deal with anycast deployments, where practically, you know, the closest node, it's always used. So you could send the request from this node to the device, and the device could reply to another Kamailio node, which doesn't have the transaction. But then what actually it's the working mechanism here, it's the second node says, okay, I got the reply, I don't have the transaction, and it's delegating the processing to the other node. You could do that by sharing some states using Redis, like I say, by call ID or whatever you have it. I discussed, like Simon had also yesterday about it. But you can do it with SIP only by adding like an ID of the server or even the IP address of the server as a parameter in the via header. And then when you get the reply, practically you look at the via header, you get the address, it's not me, then I'm just delegating by, you know, just send it there without consuming anything. You can even add some extra information like the source IP local socket in case you listen on multiple sockets. So on the other node, you can switch the context of the processing. So you can communicate between the nodes using a private node, private link. But on the server itself, you say consider as being received from that IP address, consider as being received on this socket, not on the private link. So practically, these helper functions that you can combine if you need. In the past, I did usually anycast on or transparent proxy using a single socket, and then I didn't need to switch the context. But this would be practically the snippets you have. Soon I'm going to publish a larger, more complete configuration file. So if you are dealing with this, it's something to expect soon. We had also a lot of work or contributions from the community on working with NonSIP messages for various needs, and one I'll have a bit closer to the end about IoT. So processing NonSIP messages, one would be these diameter messages, but actually could be any kind of message. We have now some event routes, and this is an example that we had in the Corex module. Practically, you have a callback, an event route where you get binary data. And this is an example of like compressing, decompressing using a Perl script. So you get completely binary data on Kamailio socket. You decompress it, you push it in the normal processing way, like request route and so on. And just before sending, you get another call of this event route network MSG, where you kind of compress it before sending it out. And you can do all kind of protocol extension or optimization for IoT and so on using this mechanism. Another use case for this transparent proxy, which I made it as a dedicated function, was this forwarding HEP packets, if you are familiar with Homer SIP capture. And if you wanted to divert it in a way or another, was possible before with send, but I made it clear in the SIP capture because it's what people are looking at typically. And we had lots of other features. I'm gonna also cover some of them in the next slides. Improvement to this authentication authorization mechanism as using stronger algorithms or optimize it to reuse trust of TLS connection and so on. Let's say inspiring from other like web services where they don't have this challenge authentication mechanism, like using API keys to trust Kamailio nodes. You could extend it to the device if you implement your own app. So I'll again come back to it. For the classic voice over IP, voice over LTE, as I said, these kind of use cases with Kamailio are really well approached. We had 6th edition of Kamailio, then I usually do presentation to many other events like AstricCon or ClueCon. So what's actually important, these are the features you can use, of course, load balancing, presence, a lot of net traversal security, transport layer, UDP, TCP, SCTP, which is rather new, TLS, IPv4, IPv6, it's there for ages. But if you go to these links, practically you see a larger set of the feature. The second one, kamailio.org/events, it's where we have slides of the most pretty much all the events we had presentation to. So if you look there, probably is now like 30 from like 10 years ago up to today, all the Kamailio World or ClueCon, AstricCon, the slides are there and usually are showing something how to do with Kamailio, like list code routing, load balancer, and so on. And then we have the Kamailio World channel with very nice recordings of the session and the past Kamailio editions. Will be 2 slides just to show the typical use case for load balancing. Practically, it's rather simplified now. If you have a basic load balancer, it's using dispatcher, and those will be like the route blocks you need to add to the default Kamailio configuration file and use it for sending out instead of just calling T-relay for the initial invite. So rather simple configuration file. Dispatcher just got a bit of refactoring internally. From the config file, like routing blocks, you can still use it, but we optimize, or I did the work to optimize some of the internal behavior to be faster and use the latest internal API. There are other contributors from the community to index it in a faster way. We use like a linked list before. Now it's an AVL tree, so it's faster searching for next destinations. LCR, it's classic, like finding the cheapest route there. We have LCR module, but then you can use carrier route, derouting, or you combine like M3 and dispatcher. There are variants of doing list code routing engines with Kamailio. On the voice over LTE mobile networks, one of the most demanded use cases was this, like suspending the incoming call, pushing a notification to the device to wake up, wait for the registration, and then forward the invite. So all this with push notification, you should eventually see Federico Cabido, who yesterday had presentation about Homer. He did most of this work. So practically, you can create branches as you get new registration. So if the user has like 2 devices, one is registering now, you send the invite, you don't wait, then you get another registration, you send it, you don't wait for replies from the first branch. So it's very flexible and dynamic. He had presentation like 3 years ago, and 2 years ago at Kamailio World with examples there. There are also recordings, so I'm not focusing on this one, but it's something that we have, let's say, done there for a long time. In the WebRTC space, we had support for WebSocket, like SIP over WebSocket, and I'm glad that someone else did it. Another Englishman, Peter Dunkley. I haven't met him in the British, Scottish. Sorry, he's not here. Okay. Yeah, another British guy then, another human. But yeah, it's stable. It's relying on our scalable TLS framework, which is also doing asynchronous connectivity and transmission. So it's not only Kamailio here. You will also need on the client side the JSIP. Iñaki, it's here. It's one of the main authors, or other JavaScript libraries. But if you just need to communicate from a browser to browser, you can just use Kamailio alone. You don't need anything. However, if you need to bridge, and here it's where actually a very interesting application, if you haven't used it, probably you missed a lot so far, so try to look at it. It's RTP engine. So you can use it together with Kamailio to make a gateway between WebRTC and classic SIP devices. So it's doing decryption, encryption as it needs, left and right, with the classic telephony, old SIP devices, or even PSTN and so on. It has more feature than that. It can record the call, and lately has another like transcoding. So you can even use it for transcoding these days. And quite interesting feature, you can use a pair of RTP engines to have high availability of the active sessions together with the Redis. So practically you have 2 RTP engines connecting to the Redis. If you shut down these active calls on this Redis, are now routed to the other. Of course, you have to use shared IP and things like that. So it's really a very nice application. It's also very scalable. You can do in-kernel forwarding rules, so the quality of the service is way better. Now I'm going into this part, which is a bit more like tips or hidden features that we had and could help you with this, like IoT, small or big devices, and elasticity for cloud. So a couple of scenarios would be, especially on some deployments, you would like to reduce the number of messages, and one of them would be registration for like, I checked it even like 1 week ago because someone asked about this. We have it there, like remote registration or mid-register functionality. We added in 2010, but it's part of the UAC module. So practically, you can get registration up to Kamailio at whatever rate, but from Kamailio to the next node that could be the main register or a PBX, it's up to you to decide a different rate of registration. So you can have every 5 minutes here and 1 hour registration expiration to the PBX. So it's in the UAC module. We had contribution from many community members, so it's rather used, and then practically you map between the incoming registration and outgoing registration. You can have even different IDs, so you have this UAC reg lookup to match between these 2 users. Of course, you can use the same user, and then you kind of skip. You just do directly lookup location if you don't have different IDs between device and the PBX. You can generate new requests if you want, like notification with the same module, the UAC. So practical here is like generating a key MSG to pass information between Kamailio nodes. So it doesn't have to be a standard method like, I don't know, option request or buy or invite. It's up to you to use the method, and then you put some headers, you put the body, and you just send it out. You have an event route to handle the reply. So this it's another way to pass states between Kamailio nodes and reduce overall communication, so you can serialize more information in a single message. Then, of course, the usual things like randomized registration value. So if you know it's a reliable device, you can say register every hour because it's on a fixed line. If you see it's a mobile app, then you can make it lower. And based on that, you have full flexibility. So it's per registration, is not like a global. Of course, you can use some of these modules for limiting, and then you can reject with a retry after. If something happens and you get a big wave, like a tsunami of the messages, you can say try after 10 seconds, after 30 seconds, and so on. Another optimization that you could do is switching to a reliable transport layer, such as TLS or SCTP, TCP, but typically lately it's TLS because it ensures also a bit more than reliability, respectively, on security and privacy part. And also you get rid of all these NAT option keep alives that could create traffic between devices. Typically with IoT, could be either the power, that it's a limitation, either the processing capability. As you deal with maybe small devices, you also want to, let's say, make the size of the messages lower. We have a lot of tools like removing unnecessary headers or unnecessary parameters from the message, removing codecs or information about the media streams. Like if you don't own video, you can remove the entire video part from the SDP. So this can help you a lot. We have many combinations, like removing on regular expression or matching the name or having an exception to skip some of the matching names and so on. And also with the codecs by ID, by media type, by name. So all kind of such options there. And then it's reducing the size by, acting more or less like an SBC back-to-back user agent. So by using Topos module, you will see messages as being originated by Kamailio. So we get the invite coming to Kamailio with maybe some context, some via header, some record route. But when Kamailio is forwarding, instead of keeping them, it's stripping them by storing them in a Redis or a database storage, and sends out with a single via, contact being Kamailio, no record route, and things like that. So like a clean, new invite. This is rather simple. You just need to load the module. You have to put some parameter to connect to the backend, but otherwise, nothing to do in the config file. Everything is done transparent inside the Kamailio config file. Everything looks like being a clean proxy. So you see all the via headers, you see all the route headers. It's only at the beginning, if we don't have, we add them, and at the end, when we send out, we strip them. So practically, you don't need to change anything inside your config file. There is a limitation. It doesn't support spirals right now, so it's more like a back-to-back user agent from this point of view. We'll probably add that feature soon. But if you are facing issues with size, that's one stop to look at. And now we are moving to some optimization on like authentication and security. We had contribution from companies adding more strong hashing algorithms for the classic authentication methods. I added this one, AuthX keys, which is practically inspired. I inspired myself actually from the GitHub, how you interact with the GitHub API. So you have like a key, and based on that key, you are hashing over some values. In our case, it's up to you to decide what your like local IP from URI, request URI, and some header. And when you check it, practically you have to get the equivalent hashing variable. So here we use source IP instead of received local IP. For TLS module also, I did some optimization in the way that sometimes makes sense to trust the TLS connection. So when you accept it, you see it's a valid certificate for your deployment. Then doesn't make sense to ask again for username and password, because TLS connection, it's not easy to spoof, and you can cache the relation between user ID from username and the connection ID. And then you just trust it. You don't do challenge as usual. In terms of scalability, and I'm finishing with this section, of course, load balancing. Kamailio, or a proxy, is known for its capacity of handling a lot of traffic, and then if you need to distribute traffic across a farm of Asterix, FreeSwitch, or other boxes, we have dispatcher being really flexible, probably now around 15 algorithms to round-robin colo distribution, weight-based distribution, so a lot of options to choose between them. And very popular rate is DMQ module, which is distributed message queue, which is using SIP. We are very good at handling SIP, so we are not reinventing another protocol. So this also gives you flexibility to route with Kamailio scripting language what you do with this messages. So practically, when you enable DMQ, you see this KDMQ messages between Kamailio nodes, sharing states about location records, dialogues, presence, and so on. And scalability on the local system. So we have the asynchronous processing. You can do like asynchronous inserts to the queries to the database, or asynchronous HTTP queries. This is relying on this: suspend the invite, do some operation, and later when you get the response, you resume the processing of that message. Meanwhile, you process other SIP requests. And here we have a couple of modules like async. You can combine MQ with rtimer, SQL offsets, or if you need to communicate with other not Kamailio related, we have message queues like RabbitMQ, MSQ, and an event API module, which is pushing JSON documents, waits for the response, and then continues its processing. Here it's a simple example by using async module. You have here the request route, we got the invite, and then we delegate to another worker by using async task route, the name of the route block. So practically this route block, it's executed in an async worker, not in a SIP worker, what we have as. And then here the SIP worker finished, could get now registered by and so on. Only this, it's executed on another process. So practically, if you see, maybe it's doing a DNS query, that's going to take late, maybe you expect to take some time, you delegate it to an async worker. So practically, this is the presentation I wanted to give here with some insights, or some maybe a little bit hidden. They are public, but some people maybe didn't spot them, like register is, like mid-register is part of UAC module, or you can use this key-based authentication between nodes. I think I have like maybe 1 minute for questions, right?
Yeah, 1 minute, 5 seconds if there's any quick questions.
So, any question you have for Tori?
Just going back to the Anycast.
Yeah.
So you said that in the case where the response goes to the Kamailio that doesn't have the transaction, you can forward it to whoever. Are you just doing then a stateless forward? But that would add an extra via header still. That would mess things up.
No, that's, I mean, as I said, there was this send function. We had it for a long time ago. This send is not like forward. It's another function. There is a function called send for 10 years there.
Okay, so you just send it without changing the SIP message at all?
Yeah.
Ah, okay.
So this, it's like just getting the buffer, sending out.
Okay, and you said there was a way to, alternatively, to extract the transaction from the other node on demand, or?
Not extract the transaction on demand. It was more like when you forward the request, you add your local server ID or local IP to the via header, and then when you get the reply, you see that token doesn't belong to you. And then based on it, either it's the IP and then you just send to that IP, or it's an ID and you look up the address behind the ID and you send it out there. So not extracting the transaction, but you can check it's not a local transaction, so then you push, like you send without any changes. Actually, you can do changes by adding some headers, but not consuming the via or consuming this. It's just some changes you want to do, not the one we do implicitly by forward or T-relay.
Daniel, that's fantastic. Thank you very, very much.
Thank you for coming as well, and I have some.
Okay, guys, we've got about 8 minutes before the next session starts. If you want to stretch your legs very briefly.